Urthecast was founded about 4 years ago with the premise of the overview effect. Astronauts go to space and they come back fundamentally changed. They express an ability to sense the fragility of the world as they overlook the planet below. Up here are perched now are 2 cameras that have been installed on the ISS, and our friend Sergey here with the world's most famous selfie. You'll see that here in a second. Eat your heart out, Kim Kardashian. We have our 2 cameras perched up here. One is pointed down all the time at the Earth, and one is on a robotic arm, able to follow out and slew down and follow a target on the ground. And you can see it there in the background. The premise here is to provide an evocative and provocative experience of what used to be very static imagery. You go to Google Maps and you see who knows when that was taken of that imagery. And we are taking this data down and we're trying to send it out on the web in near real time. And by doing so, we can evoke a feeling of ever-changing the world below. And those stories, we'll come back to that, but those stories that are evolving on the planet tell us something about ourselves. We have also teamed with NASA to stream the ISS view of the world in real time. You can go to our website and see what's going on in the ISS right now as we speak. And this perspective allows us to gain a sense of self. Everyone looks in the mirror once in a while. You lean in, you kind of brush your teeth, maybe you got to lean in a little closer and pop a zit. And the idea here is to let us see the world below for what it really is and evolve with the world below. This video is from our camera up on the ISS. This is Fukushima. This allows us to actually see the world in near real time and sense actionable information. What these cameras allow us to do is actually perceive data. The data within those cameras have a lot more information than our eyes can pick up. We have near infrared and some other things. And with that amount of information, we're allowed to use that for a lot of different things to tell stories. We are now, as a company, evolving ourselves, and we have 2 more cameras that we have part of our growing suite of sensors. And those sensors allow us to see video, kind of the overview of the world, and we have 2 new cameras that allow us to see the detail of New York City. We can see farmland and so forth. The rapid change that the world goes through every day, this data can be used to quantify it. But behind every image, there's a story, and with that story, we have to back it up with data. And you can see the verticals here that we concentrate on: forestry, environment, insurance, trading, commodities. We can see how this data traverses the entire human experience. The new model that has arisen, this is Palmyra. We were the ones who took the before and after imagery, and that was on CNN, as well as working with the UN to help monitor this World Heritage Site. Looking back at those different use cases, we actually have evolved the use cases. Big data, the compute power that is now present, allows us to do things like machine learning, deep learning, neural networks, and so forth, and allows us to look at commodities markets, social media integration, conflict avoidance and prediction. The world is now quantifiable. The idea to monitor these locations on the planet is to programmatically experience these changes. With every area that I'm going to be monitoring, I'm able to push data into that AOI and also subscribe to events that are changing. So if there's an earthquake or a fire, I can subscribe to that event stream, and then I can programmatically request imagery. Or if my analytics package is doing something with that data, I can actually put that back into the system as well. And it's a programmatic experience to quantify the planet. We've short-circuited what developers have to actually do to make sense of this imagery. Up here you see 4 examples. One is called NDVI. It tells us a little bit about vegetation health. We can use this type of imagery to look at the health of crops, farmland, change detection on places like a Hungarian refugee camp. False color NIR, the next one over to in the middle, allows us to see forest health and deforestation. The other two indices allow us to see a lot more that the human eye cannot do. Our platform is now live, and it allows developers to go in and access data that has been normally locked behind a firewall. It's been siloed, it's aging, it's kind of long in the tooth, and what we are trying to do now is unlock its true potential. Here's an example of when you log into the platform, a developer can quickly change on the fly different ways to look at the planet and quantify that. And this is farmland outside Bakersfield in California. And using this type of technology, I can look at the health of my farmland, or actually the productivity of my farmland, which is now something, the economic value of this data becomes much more evident. The platform is software as a service, so anyone on the planet can actually access this type of data now. It used to be a governmental type initiative to gain access to this type of imagery or intelligence, but now we want to unlock its true potential. And by doing so, we give a full suite of business tools to monitor, analyze, and respond to the temporal changes on the planet at a global scale. By understanding these types of changes, we can see daily insights of what's happening. And this data allows us to quantify things like the amount of containers at a shipyard, the amount of oil in crude oil storage here at a port, the amount of ships at a port, things like that. This is video taken from our camera on the ISS and allows us, you can see as in a moving example, things that are happening in real time. You can see even up in the left corner, some ship dock carriers moving containers throughout. Counting cars, counting ships, counting containers at a port, all of these become an indicator of the activity of, say, something like GDP. We can now start predicting GDP on the planet for any given country. Again, as I was saying before, using this type of imagery allows us to see what's inside that story. What do we quantify within that story? This is a military base in the Middle East. We can even see personnel walking, an activity in an installation that should not be active. What does this tell us about ourselves? Again, it's our ability to look at ourselves in the mirror every day. Looking at this data as well allows us to respond in manners that are unprecedented. We can look at false color NIR image, and you can see the actual hotspots of where the fire is actually burning outside a reservation land here in the Mojave. And by responding in a certain way and looking at mashing this data up with weather data, other types of data that you can actually say, I need to protect these farmland or protected forests. And we can push that forest fire or brush fire here in a specific direction to optimize our response. As this plays out, as you can see this imagery, those were specific examples. But if you look at this at a global scale, we're able to put a distribution model, because it's all API-based, it's a platform-based. We are now working with the World Resources Institute, and they have an initiative called the Global Forest Watch. And Global Forest Watch seeks to quantify the net loss and gain of forests around the world every day. And we're able to help provide some assistance with our data sets to help do that at any location around the planet. Another good example here is this is a NDVI, a vegetation health example of pivot irrigation in Saudi Arabia. Pivot irrigation is not the most optimal way of irrigating a mostly arid place on the planet in Saudi Arabia. And how do we look at this information and quantify the efficiencies? This is our next gen. And part of the problem here with our data sets that come from optical cameras is that we're covered with clouds about 50% of the time anywhere on the planet. So what we are creating is a series of satellites that fly in tandem, and this is going to be our radar satellite that flies in front of an optical satellite and is able to see through clouds and even penetrate the canopies and see what's below. And that allows us to see things like illegal logging happening, tanks, all kinds of things. And you can see this data at large can see the weather change per season, per year, per decade. Poor Canada, you can see the winter here. Come on. I want to leave you with a couple thoughts here. For every image, we do have a story. Urthecast is bringing that to you as an end consumer or a developer. We all have a quantified self, and so does the planet. And we seek to evolve with the planet and assist the planet by giving that data to the innovators and the developers that are here in this room and at this conference so that we can evoke a sense of self and belonging with that planet below. Thank you.